Suppose calculus isn't sitting right with you and you can't understand what's going on. But no worries, mon ami. I might be able to explain what calculus is to you. So calculus is based on two fundamental concepts, derivatives and limits. Starting with limits. Suppose I asked you how you would calculate 1 over 0. Normally I would expect you to say, well, as we are decreasing the denominator, the value gets bigger and bigger, so I suppose it will be infinity. What you just did there is find the limit of 1 over x as x approaches 0. Let's see how this function works with another example. Suppose I ask you to calculate this. Well, infinity here means never ending, so we have to use bigger and bigger numbers. For 10 we get 2.59, for 100 we have 2.704, for 1000, 2.716, for 10,000, 2.71814, 100,000 gives 2.71826. Now we can definitely say that our x is approaching infinity, but our expression is not. It seems to get stuck at some value that is approximately 2.718, so as x approaches infinity, slowly, but obviously not surely, the expression approaches e, so that is how limits work. So now that we know that limits are used for calculations where you cannot just replace stuff with or when it is impossible to know for sure what it evaluates, we can look at what a derivative is. So first we need to know what a function is, which I'm sure most of you do, but bear with me. So a function is kind of like a machine, and it takes an input and gives an output. Let's say I wanted to see a graph of how our input changes with how fast our output changes. Take input on the x-axis and output on y-axis. Oh, that's quite useful, but I still don't know how fast my output changes according to my input. Well, let's say my input changes by x and output changes by 2x, so we divide both and we see that output changes twice as fast as my input. So now we know what to do. To find out how fast my output changes is to divide change in output by change in input. Let's say my input changes by h, a change is often written as a final value minus initial value, so assume my initial value is x, so my final value is x plus h, and to find change in output, final output minus initial output, so this our formula, if I wanted to find how fast my output changes a certain input. You may not understand what I'm talking about, so let's talk in terms of graphs. How fast something changes is represented by a slope, so what I'm saying is, what is the slope at a particular point? Well, we can see that x or input doesn't change, so let's say the change in input goes to 0. Let's actually evaluate that for x squared. Since f of x is x squared, f of x plus h is x plus h whole squared, so this outputs to 2x plus h, and we can see that the value of x squared is increasing at twice the speed of the current value. This is known as the derivative of x. Some applications of derivative are, for example, there is a force that accelerates an object, and the force increases at a rate or 2 newtons per second, so acceleration would increase at 2 meters per second squared per second. Now acceleration is just rate of change of velocity with respect to time, so the derivative of velocity is acceleration. Now the derivative of x squared is 2x. So it can be concluded that our velocity time looks like an x squared graph, if an acceleration like this is continued. So now we know what a derivative does, we have understood most of calculus fundamentals. So integration is the opposite of derivative. So let's actually take a look at the graph of the derivative, and suppose we don't have the original velocity graph and all we know is that this depicts the acceleration or how fast velocity changes, and we have to find the graph of how velocity changes. So let's first calculate at intervals of 1 second. We start at 0 for 1 second, so velocity changes by 0, now after a second, acceleration changes by 2 and acceleration into time is velocity, so that is the amount by which velocity increases. We continue this similarly and then we do it at 0.1 second intervals and 0.01, we can see our graph forming shape and our method starting to look like the area under the graph. So if we find the area under the graph of the derivative we get the original graph, and if we integrate a derivative we get the original function, so the integral of a function calculates the area under the graph of a function. And now that we know the concepts, let's see how we evaluate derivatives or integrals. Using the formula of derivative we can also find the integral by assuming the function is a derivative of some function, which may not always be true, but that is way too advanced for now. So the first formula is that the derivative of a sum is the derivative of each individual term. Just look at the formula and replace f with g and h, do some grouping and you can totally evaluate these individually. The derivative of a function with a constant factor is just the constant factor times the derivative. Using the same trick as last time, take c common and you could just do this individually as the constant doesn't affect the inside terms. The power rule, this might be a bit hard to prove, so bear with me. So during the differentiation, another word for finding the derivative, we raise a whole sum to a power, so let's take a look at the Pascal triangle. These are the coefficients of x plus 1 raised to the corresponding power. Let's look at it from our x plus h perspective. The power of x decreases and power of h increases, so since we are subtracting from this, let's remove the x to the n terms and then we have to divide by h, so decrease power of h. Now, only those without h will survive, as h approaches 0 and 0 times anything is 0. Since they had only one h, the power of x is decreased by 1 and it is multiplied, and the coefficient corresponds with the power, so the derivative will have 1 less power and the exponent multiplied at the front, and there we go, we have proved the power rule. Correspondingly, the integral will simply have to invert these laws because they are their arch nemesis. But the sum and multiplication laws remain. If we come across this in an integral, we know that it will lead to this. So we take constant out, we divide this constant over here using algebra and then realize n is just a constant and you can just add 1 to all n and get the formula. That is all for this video, however there are way more methods to solve integrals which I will cover in part 2. Bye for now.